When we type in the input box, sometimes there will be a prompt to guess the possible final result. So how does it achieve? Today we will introduce a basic data structure tree. It can complete the task of auto-completion more efficiently. For example, there are two strings. They have a common prefix y. We can merge their prefix, connect them. Here is another string. You can continue to merge, so and so on. This is the structure of a tree. This tree merges the common prefix in the string as much as possible. Then when we import a prefix, you can find the last node O based on the prefix. Then all its child nodes are traversed once, and all possible results are obtained. They are YO and U, plus the prefix, which is the two cases. Specifically, the content contained in each node is represented by the struct of the C language. There is an array of pointers to children. The length is 26, which corresponding to the number of English letters. There is also a Boolean value, which represents whether this node is the end of the string. Well, with the basic structure of each node, we will mainly introduce the operation, insertion and search of the tree. The first is the insertion operation of the tree. Assume that the string key is like this. The first is the pointer of the root node root as the current pointer. Each node is a struct, then traverse all the characters in the key. Here you need to convert the characters to the corresponding number index. For example, A represents 0 and Z represents 25. Now it is Y, so the index is 24. Next, check whether the 24th item in the children array has a pointer. If not, create a child node at that location. Then the current pointer points to this child node. And so on after a few cycles. That is it. Jump out of the loop and mark the end of the word yes at the last node. Next, we insert the word again. The current pointer pcurl initially points to the root node. Then, after several rounds of cycles, the last is marked as the end of the word. By analogy, we have built a tree. Then there is the search operation. Now, first import YA starting from the root node. Then iterate through each character. Then get the child node Y according to the index. So sure to exist. Then the current point to the child node Y. Continue the loop if the child node corresponding to an array not exist, it returns false to end of the search. If you enter YO, then the traverse can be completed and the current point is to O. However, in the end, it is necessary to determine whether it is the end character of a word. Here node O is not, and it returns false. Then, if it is YO, which point to the O node, it can return true. Okay, let's summarize. The tree supports efficient insertion and search. However, hash also has the same characteristics. The tree can be traversed, but hash is not. It is used in application scenarios such as prefix matching search. However, if you can also see that the length of the children's array is the size of the character set, then, for example, the collection of Chinese may be very large and it may be implemented together with the help of other algorithms. Alright, this video is here. See you in the next time.